Today we'll study transformations of a graph. So we'll take a basic graph, we'll apply the transformations, and from that we'll get stunning and more complex graphs. So we'll start with our first transformation. Our first transformation is shifting along x-axis. Suppose I'm given the graph of y equals fx, and now I want to draw the graph of fx plus a. So what I've done is I've simply changed this x to x plus a. So in order to draw this graph, all I need to do is shift the entire graph minus a units along x-axis. So I'll just move the graph horizontally. So I'll take up an example. Say for example, suppose I have to draw the graph of y equals mod of x plus 2. Now what's my basic graph? Basic graph here is y equals mod of x. So I'll draw the graph of mod x. For mod of x plus 2, I'll shift the entire graph minus 2 units along x-axis. So that's the graph of y equals mod of x plus 2. Now say for example, I have to draw the graph of y equals mod of x minus 1. So now again, I'll take the graph of mod x and then I'll shift the entire graph plus 1 units along x-axis. Suppose I need to draw the graph of y equals 2 x minus 3 whole square. So what's my basic graph here? The basic graph here is y equals 2x square, which is a parabola of the third form. It is parabola opening upwards, vertex at 0. Now for x minus 3, I'll shift the entire graph plus 3 units along x-axis. So now that's the graph of y equals 2x minus 3 whole square. I'll take another one. I have to draw the graph of y equals fractional part of x plus 1 by 2. So my basic graph is fractional part 1. Now for fraction part of x plus 1 by 2, I'll need to shift the entire graph minus 1 by 2 units along x-axis. So now that's the graph of y equals fractional part of x plus 1 by 2. Now second transformation is shifting along y-axis. So suppose I am given the graph of y equals fx and I have to draw the graph of y plus b equals fx. Then all I need to do is I need to shift the entire graph minus b units along y-axis. So I'll just have to move the graph vertically. Now suppose I want to draw the graph of y plus 2 equals 3x square. Now what's my basic graph here? My basic graph is y equals 3x square. Y equals to 3x square is basically a parabola opening upwards, vertex at origin. Now for y plus 2, I'll shift the entire graph minus 2 units along y-axis. So I'll take up this graph, I'll shift the graph minus 2 units along y-axis. So now previously the vertex was at origin. Now this vertex has shifted to 0, minus 2. Suppose I want to draw the graph of y equals 1 plus cos x. Now the first thing that I need to know here is it's not a transformation of x, it's a transformation of y. Basically I can write it as y minus 1 equals cos x. So my basic graph here is y equals to cos x. Now I need to draw the graph of y plus 1 equals cos x. So what I'll do is I'll shift the entire graph plus 1 units along y-axis. So previously this graph was between minus 1 and plus 1. Now it will lie between 0 and 2. So I'll shift the entire graph plus 1 units along y-axis. So that is the graph of y equals 1 plus cos x. Now this third transformation is basically a combination of first two transformations. So from y equals to fx, we need to draw the graph of y plus b equals fx plus a. Say for example, suppose I have to draw the graph of y equals 1 plus mod of x minus 2. So basically I can also write it as y minus 1 equals mod of x minus 2. So my basic graph is y equals mod x. Now here I need to transform the graph so that x becomes x minus 2 and y becomes y minus 1. So I'll shift the entire graph plus 2 units along x-axis and plus 1 unit along y-axis. So either I can take both the transformations simultaneously or I can go sequentially. Say for example, from mod x, I'll go to mod of x minus 2. So first I'll shift the graph horizontally. So suppose I've shifted this graph plus 2 units along x-axis. Now for this graph, shift this graph plus 1 units along y-axis. So now I'll move this graph upwards along y-axis. Now let us take another example. So basically it's a rational function. Now what I can do is I can write this as x plus 1 minus 3 upon x plus 1 or y equals 1 minus 3 upon x plus 1. So y minus 1 equals minus 3 x plus 1. Here I can identify my basic graph. So if I take this as y and if I take it as x, so my basic graph here is xy equals minus 3. Now xy is equal to minus 3 is a rectangular hyperbola of the second form. Now from this graph, I'll first draw the graph of y equals minus 3 upon x plus 1. So it's a transformation of x. So I'll shift the entire graph minus 1 units along x-axis. So previously the asymptote which was at 0, now this asymptote will be at minus 1. So if I'll draw this graph, so I'll draw this asymptote and now that's the graph of y equals minus 3 upon x plus 1. Now from this graph, I'll draw the graph of y minus 1 equals minus 3 x plus 1. So for this graph, I'll just need to shift the entire graph plus 1 units along y-axis. So that's the graph of y equals x minus 2 upon x plus 1. Now we'll move on to our fourth transformation. And the fourth transformation is from the graph of y equals to fx, I need to draw the graph of y equals minus fx. So one way of doing it is rotate the entire graph 180 degrees along x-axis. Say for example, suppose I know how to draw the graph of y equals to sine x, and from y equals to sine x, I want to draw the graph of y equals minus sine x. So from sine x, if I have to draw the graph of minus sine x, so if I'm going to rotate the graph 180 degrees along x-axis, so I'll end up getting this graph. So that's the graph of minus sine x. Another way of doing it can be, so I can take a two-way mirror and I'll place it on x-axis. So if I take a two-way mirror and if I place it on x-axis, I'll take the reflection of this graph about this mirror. So that's the graph of y equals minus sine x. I'll take another example. Say for example, I have to draw the graph of y equals minus mod x. So that's my mod x function. Now, if I place a two-way mirror, so if I take the reflection, I'll get this reflection. So that is the graph of y equals minus mod x. Graph of f minus x. So here I have replaced this x with minus x. Now, how do we do that? Now for this, I need to rotate the entire graph of 180 degrees along y-axis. So previously the value which was at plus 1, now it will be at minus 1, and the value at minus 1 will be at plus 1. So clearly I need to rotate the entire graph of 180 degrees along y-axis. Say for example, suppose I have to draw the graph of y equals greatest integer function of minus x. So my basic graph is y equals greatest integer function of x. I'll rotate this graph 180 degrees about y-axis. So if I'll rotate it about y-axis, so the graph I'll get is, now another way of doing it can be, I can place a two-way mirror and then I can start taking the reflection of left on right and right on left. So if I take the reflection of right, I'll get, and if I take the reflection of left, I'll get this value. I can rotate the entire graph 180 degrees about y-axis, or I can place a two-way mirror on y-axis and then I can reflect the entire graph. Now I'll take up another example. Say for example, I need to draw the graph of y equals minus of under root of minus x. So my basic graph here is y equals under root of x. Now first I'll draw the graph of y equals under root of minus x. Now for under root of minus x, take a mirror on y-axis and take the reflection of right on left and left on right. So if I'll take the reflection, I'll get this graph. So that's the graph of y equals under root of minus x. Now for y equals minus under root of minus x, now I'll place a mirror on x-axis and I'll take the reflection of down on up and up on down. So if I'll take the reflection, I'll get this graph. So that's the graph of y equals minus under root of minus x. So we'll move on to our sixth transformation, and this transformation is from the graph of y equals to fx, we need to draw the graph of y equals afx when a is a positive number. So say for example, from the graph of y equals sine x, I need to draw the graph y equals 2 sine x. Now depending on the value of this a, we have to either stretch or shrink the graph in vertical direction. This is the graph of sine x. Now for 2 sine x, I need to stretch the graph along y-axis. So previously its amplitude is between -1 and +1. Now it will be between -2 and +2. So basic shape will remain the same, only its amplitude is going to change. So we have stretched the graph along y-axis. Suppose I have the graph of y is equal to x square, and from that I need to draw the graph of y equals 2x square. So for y is equal to 2x square, again I'm going to stretch the graph upwards. If I'm going to stretch the graph upwards, I'll get this graph. So that is the graph of y equals 2x square. Now what about y equals 1 by 2x square? Now for y equals to 1 by 2x square, I'll need to shrink the graph. So if I'll shrink the graph along y-axis, so I'll end up getting this graph. So basically from the graph of y is equal to x square, I can draw the graph of y equals to 2x square, and I can also draw the graph of y equals 1 by 2x square. So for 2x square, I'll stretch the graph, and for 1 by 2x square, I'll shrink the graph. Now seventh transformation is from the graph of y is equal to fx, we need to draw the graph of y equals fax. Here again, I have taken a as a positive number. So here too, I need to stretch or shrink the graph along x-axis. Now say for example, from the graph of y equals sine x, I have to draw the graph of y equals sine 2x. So I'll draw the graph of sine x. So for sine 2x, I'll shrink the graph along x-axis. So previously, period of this function was 2 pi. Now the period of this function is pi. Now for trigonometric functions or for any function, the simplest way of doing this transformation can be, so if from the graph of y is equal to fx, you have to draw the graph of y is equal to fax, then divide each and every value with a. So from the graph of sine x, if I have to draw the graph of sine 2x, so what I'll simply do is, I'll divide all the values with 2. So basically, I'll get the same graph, little bit zoomed out. That's it. Suppose I have to draw the graph of y equals fractional part of x by 2. So I'll draw the graph of fractional part of x. And since it is 1 by 2, so I'll multiply every value with 2. So this is 2, it is 4, this is -2, and then it will be +4. So that is the graph of y equals fractional part of x by 2. And the fundamental period of fractional part of x by 2 is 2 units. Now we'll come to the very important transformations of modulus function. So from the graph of y equals to fx, I'll need to draw the graph of f mod x. I'll take a very simple example. Say for example, I need to draw the graph of y equals e to the power minus mod x. So I'll start with, I'll draw the graph of e to the power minus x, which is a decreasing function. So for this transformation, there are two steps. First step is, erase the graph from second and third quadrant. So I'll draw the same graph, but I won't draw it in second and third quadrant. So this is first step. Now second step is, place a mirror on y-axis. So place a mirror on y-axis and then take the reflection of right on left. So if I'll take the reflection of right on left, I'll get this graph. So that is the graph of y equals e to the power minus mod x. I'll take another one. Suppose I have to draw the graph of y equals x square minus 3 mod x plus 2. So basically, mod of x square is same as x square. So mod of x square minus 3 mod x and plus 2. So I can write it as mod of x minus 1 and mod of x minus 2. My basic graph is y equals x minus 1 into x minus 2, which is parabola opening upwards, roots at 1 and 2. So that's the graph of y equals x square minus 3x plus 2. Now I'll replace x with mod x. So my transformation is erase the graph from second and third quadrant and then take the reflection of right on left. So that is the graph of y equals x square minus 3 mod x plus 2. Now what about this? Y equals ln mod x. So I'll draw the graph of y is equal to log x. For the transformation, I'll erase the graph from second and third quadrant. So basically there is nothing in the second and third quadrant, and then I'll take the reflection of right on left. So that is the graph of y equals log mod x. Now the ninth transformation is from the graph of y equals fx, I need to draw the graph of y equals mod fx. Now say for example, I have to draw the graph of y equals mod of sin x. Now for mod of sin x, my basic graph will be y equals sin x. So I'll draw the graph of y equals sin x. Now again there are two steps. First step is mirror on x-axis and then take the reflection of down on up. So I'll place a mirror on x-axis and I'll take the reflection of down on up. Then erase the graph from third and fourth quadrant. So that is the graph of y equals mod sin x. I'll take another example. So I need to draw the graph of y equals mod of x minus 1. Now there are two ways to draw this graph. The first way is I can draw the graph of mod x, and then from mod x I can draw the graph of y minus 1 is equal to mod x, and then I can draw the graph of mod of x minus 1. So if I'm going to draw the graph in this way, then first I'll draw the graph of y is equal to mod x, then y minus 1, shift the entire graph minus 1 units along y-axis, and then mod of x minus 1. Now for mod of x minus 1, take the reflection of down on up and then erase the graph from third and fourth quadrant. So basically the graph of mod of x minus 1 will be this W-shaped graph. So this question was actually asked in IIT. So what they have asked was find the points where this function is not differentiable. So it is not differentiable at minus 1, 0 and plus 1. It is continuous for all x belongs to R, but not differentiable at minus 1, 0 and plus 1. Another way of drawing the same graph can be, I can again start with y equals to mod x, then I can find out y equals mod of x minus 1, and then I can write mod of x minus 1. So again I'll start with mod x, then mod of x minus 1, shifting along x-axis plus 1 units, and then mod of x. So erase the graph from second and third quadrant and then take the reflection of right on left. So again I'll end up getting the same graph. So suppose I have to draw the graph of y equals mod of 2 upon mod of x plus 2 minus 1. So my basic graph here will be y equals 2 upon x, and from here first I'll take transformation of mod x. So y equals 2 mod x, and then I'll shift it along x-axis 2 times mod of x plus 2, and then I'll shift it along y-axis y plus 1 equals 2 times mod of x plus 2, and then finally I'll take mod of fx, mod of 2 times mod of x plus 2 minus 1. So y equals 2 upon x, rectangle or hyperbola. Then for mod x, erase the graph from second and third quadrant, take the reflection of right on left, and then mod of x plus 2, shift the entire graph minus 2 units along x-axis, and then y plus 1, and then y plus 1, shift the entire graph minus 1 units along y-axis, and finally mod of fx. So reflection of down on up, and then erase the graph in third and fourth quadrant. The graph of y equals mod of 2 times mod of x plus 2 minus 1 will be, so that's the graph of this given function. I'll take another example. Suppose I have to draw the graph of y equals mod of e to the power minus mod x minus half. So I'll start with y equals to e to the power minus x, and then first I'll draw the graph of e to the power minus mod of x. Then I'll shift it along y-axis. Y plus 2 equals e to the power minus mod x, and then I'll take the transformation of mod x. So mod of e to the power minus mod x minus 1 by 2. So for minus mod x, so erase the graph from second and third quadrant and take the reflection of right on left. Now for y plus 1 by 2, so shift the entire graph minus 1 by 2 units along y-axis. So now the horizontal asymptote will be at minus 1 by 2 and the maximum value will be at plus 1 by 2. So in this equation, if I'll put y as 0, I'll get x equals plus or minus ln 2. So these point of intersections will be minus log 2 and plus log 2. Now I'll take the transformation of mod fx. So mirror on x-axis, reflection of down on up, and then erase the graph from third and fourth quadrant. So basically this graph will be, so that's the graph of mod of e to the power minus mod x minus 1 by 2. So our next transformation is to draw the graph of mod y equals to fx from y equals fx. Now for this, there are two steps again. Erase the graph from third and fourth quadrant, take a mirror on x-axis, and then take the reflection of up on down. Say for example, suppose I have to draw the graph of mod y equals x square minus 1. So my basic graph is y is equal to x square, and then first I'll take transformation of y, and then I'll take transformation of mod y. So y is equal to x square is a parabola opening upwards. Now y plus 1. So shift the entire graph minus 1 units along y-axis, and then for mod y, erase the graph from third and fourth quadrant. So mirror on x-axis, take the reflection of up on down. So basically this graph will be, I'll take another example. Say for example, I have to draw the graph of mod y equals mod of x square minus 3 mod x and then plus 2. So I'll start with y equals x square minus 3x plus 2, and from this I'll draw the graph of y equals mod x square minus 3 mod x plus 2, and then from there I'll get y equals mod of x square minus 3 mod x plus 2, and then from there I'll get mod of y equals mod of x square minus 3 mod x and then plus 2. So basically it's a quadratic expression with two real roots. So I'll draw this graph. Now for the transformation of mod x, erase the graph from second and third quadrant and then take the reflection of right on left. So this is 1, 2, and this is minus 1 and minus 2, and this is 0, 2. Now for mod fx, take the reflection of down on up. So mirror on x-axis and take the reflection, and then erase the graph from third and fourth quadrant. So I'll get this graph as, and now the next step, mod y. So basically this graph will look like. So that's the graph of mod y equals mod of x square minus 3 mod x plus 2. Now one of the very important graph which is generally used in area and straight lines is graph of mod of x plus mod of y equals a. So here my basic graph will be x plus y equals to a, and then I'll take the transformation of x plus y equals a, and then I'll take the transformation of y also. So mod x plus mod y equals a. So let a be a positive number. I'll draw the line x plus y equals to a. So this point will be a comma 0 and this point will be 0 comma a. So for mod x, I'll erase the graph from second and third quadrant, and then I'll take the reflection of right or left. Now for mod y, I'll erase the graph from third and fourth quadrant, and then I'll take the reflection of up or down. Mod x plus mod y plus a represents a square. Now we'll move to next set of transformations. And next set of transformation involves greatest integer function. So from the graph of y equals fx, I have to draw the graph of y equals f greatest integer function of x. Now what we already know is if x lies between n and n plus 1, greatest integer function of x will be n. So what I'll do is I'll draw the graph of fx and then I'll draw vertical lines at integral points on x. So say for example, suppose I have to draw the graph of y equals greatest integer function of x whole square, and suppose I have to draw this graph between -2 and +2. So my basic graph will be y equals to x square, and I'll draw this graph. So in order to draw the graph of y equals greatest integer function of x square, my first step is draw the graph of fx and then draw vertical lines at integral points on x-axis. So I'll draw vertical lines at -2, -1, 0, 1 and 2. Now second step is mark points of intersection and find corresponding values of x and y. So I'll mark these point of intersections. Now what's the value at -2? So when x is -2, this value is 4, this value is 1 and this is 0. Third step is for graph between n and n plus 1, draw a horizontal line. So for graph between -2 and -1, I'll draw a horizontal line. For -1 and 0, I'll draw a horizontal line. For 0 and 1, I'll draw a horizontal line. Again here. So the graph which I have drawn in red represents the graph of greatest integer function of x square. I'll take up another example. Say for example, I have to draw the graph of y equals under root of greatest integer function of x when x lies between 0 and 4. So my basic graph will be y equals under root of x. So that's the graph of under root of x. Now I'll draw vertical lines at integral points. So I'll draw this line at 0. I'll draw this line at 1, at 3 and at 4. And I'll mark these point of intersections. Now when x is 1, y is 1. When x is 2, y is root 2. When x is 3, y is root 3. And when x is 4, y is 2. So now, in between n and n plus 1, draw a horizontal line. So I'll draw a horizontal line. The graph which I have drawn in black represents graph of square root of greatest integer function of x. Now we'll move to the 13th transformation. And this one is very important. And this is y equals greatest integer function of fx. So now here I'm taking greatest integer function around the whole function. So this is one of the very important transformations. Now I'll take up an example. Say for example, I have to draw the graph of y equals greatest integer function of x square when x lies between 0 and 2. Now what are the steps involved for this graph? My basic graph is y equals x square. So I'll draw the graph of y equals x square. So that's the graph of y is equal to x square between 0 to 2. So first step is draw y equals to fx and draw dotted horizontal lines at integral points on y-axis. So on y-axis the integral points are 4, 3, 2 and 1. Now second step is mark points of intersection and find corresponding values of x. So I'll mark points of intersection. I'll find corresponding values of x. So if I'll put y as 2, I'll get x as root 2. So this value is under root 2. And the same way if I'll put y as 3, I'll get this as root 3. Now what's the next step? Now for the graph between y equals n and y equals to n plus 1, draw a horizontal line at y equals to n for successive values of x. So between 0 and 1, draw a horizontal line at 0. Between 1 and root 2, when y is between 1 and 2, so that is when x is between 1 and root 2, draw a horizontal line at 1. In the same way at root 3, in the same way between root 3 and 2. So the graph in black is actually your graph of greatest negative function of x square. So fourth step is erase graph of y equals to fx and dotted line. So that means I'll redraw this graph. That's the graph of y equals greatest negative function of x square. I'll take up another one. Suppose I have to find this integral, which is 0 to infinite, greatest negative function of 2 upon e to the power x. So what I'll do is I'll draw the graph of y equals greatest negative function of 2 upon e to the power x. Now here my basic graph is y equals 2 upon e to the power x, or I can write y equals 2 into e to the power minus x. So I'll draw this graph. Now I need to take the transformation of greatest negative function of x. So draw horizontal lines at integral points of y. So I'll draw horizontal line at minus 2 and I'll draw horizontal line at 1. I'll mark these point of intersections and I'll find the corresponding value of x. So if I'll put y as 1, value of x will be ln 2. Now between y equals 1 and 2, draw a horizontal line at y equals to 1. Between 0 and 1, draw a horizontal line at 0. So the graph in red represents the graph of greatest negative function of 2 upon e to the power x. Now if I have to find this definite integral, I'll just need to find this area. And this area is actually a rectangle. Answer to this question is ln 2. I'll take up another question, and that question is y equals greatest negative function of 2 sine x. Now here again my basic function is y equals 2 sine x, and I'll draw this graph between x equals to 0 and x equals 2 pi. So I'll draw the graph of 2 sine x. And I'll draw horizontal lines at integral values of y. I'll mark their point of intersection. So this is 0, pi, and 2 pi. Now this is pi by 2, and this is 3 pi by 2. Now when I'll put y as 1, I'll get sin x equals 1 by 2, which is pi by 6. From symmetry, I can say this is pi minus pi by 6, it will be 5 pi by 6. And this one will be pi plus pi by 6, so there will be 7 pi by 6. And here it will be 2 pi minus pi by 6, so there will be 11 pi by 6. Now I'll draw horizontal lines. So between 0 and pi by 6, it will be 0. Then so the graph in black is actually the graph of greatest negative function of 2 sine x. And now in this graph, they may ask you to find continuity, differentiability, or area, or the value of definite integral. We can find it simply using the graph. Now the next transformation is from the graph of y equals to fx, we have to draw the graph of y equals fractional part of x. So here this bracket represents fractional part function. Now say for example, I have to draw the graph of y equals e to the power fractional part of x when x lies between, suppose 0 and 3. So I'll draw the graph of e to the power x. So now what are the steps? Steps are draw the graph of y equals to fx between x equal to 0 and x equal to 1. So I'll just need to draw the graph between x equal to 0 and x equal to 1. So this is 0 and this is 1. So at 0 this value is what? 1, and at 1 this value is suppose e. So I'll draw the graph of e to the power x between 0 and 1. And here I won't include the value at 1. Now because fractional part function is a periodic function, so all I need to do is I need to copy and paste this graph for all other intervals. So what I'll do is I'll copy and paste this entire graph. So that is the graph of y equals e to the power fractional part of x. I'll take up another example. Suppose I have to draw the graph of y equals ln fractional part of x. I'll draw the graph of ln x between 0 and 1, and I won't include it at 1. Now I'll generate the graph for all other intervals. So that is the graph of ln of fractional part of x. So now we'll come to our 15th transformation, and that is graph of fractional part of y equals fx. So from the graph of y equals to fx, I have to draw the graph of y equals fractional part of x. So I'll take up an example. Say for example, I have to draw the graph of y equals fractional part of x square when x lies between 0 and 2. So I'll draw this graph. So I'll draw the graph of y equals x square, and then I'll draw dotted horizontal lines at integral values of y. And then I'll mark corresponding points on x. So this is 1. Now when y is 2, this is root 2. Here I'll get this as root 3. And here this value is 2. Now between two successive values of x, move graph vertically to bring it between y equals to 0 and y equals to 1. So all I need to do is I need to move the graph between two successive x so that the graph lies between 0 and 1. So it already lies between 0 and 1. Now this part I'll bring it down. This part also I'll bring it down. This part also I'll bring it down. So that's the graph of y equals fractional part of x square. I'll take up another example. Say for example, I need to draw the graph of y equals fractional part of sine x when x lies between 0 and 2 pi. So I'll draw the graph of sine x. Now I'll draw horizontal lines at integral points. So I'll draw horizontal line at 1, 0, and -1. So this is 0, 1 and -1, and I'll mark this point. Now when x is an integer, then fraction part of x is 0. So for all these points, I'll mark a corresponding point on x-axis where it will be 0. So this is 0, pi by 2, pi, 3 pi by 2, and this is 2 pi. Now I'll shift the graph to move it up and down. So here it already lies between 0 and 1, so I won't change it. Here this graph, it lies between 0 and -1, so I'll move it up. So if I'll move it up, I'll get. So the graph of fractional part of sine x will be this is 0, pi by 2, pi, 3 pi by 2, and this is 2 pi, this is 1. So that's the graph of y equals fractional part of sine x. Now the one question which I have come across many times is, find the number of solutions of the equation mod log mod x equals mod sine pi. So here we have to find number of solution to this equation. So first I'll draw the graph of mod sine pi x. So for mod sine pi x, my basic graph is y equals sine x. Now for sine pi x, I'll divide every value with pi. And then finally I'll take the transformation of mod sine pi x. So transformation of mod fx is reflection of down on up, and then erase the graph from third and fourth quadrant. So I'll draw this graph. Now for mod log mod x, my basic graph is log x. Then I'll take the transformation of mod x. And then I'll take the transformation of mod log mod x. So now I'll draw the graph of mod log mod x. Now the value of log x is 1 at e, and e is 2.7 something. So this graph will be drawn like this. And in the same way on left hand side, we are going to draw the same graph. So these two graphs, they're intersecting at 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10 points. So the number of solutions to this equation is 10. Discuss the differentiability of the function y equals mod of 1 minus mod of 1 minus mod of 1 minus mod of 1 minus x. So we'll draw the graph of this function, and from the graph we'll work out differentiability of this function. So my basic graph here is y equals 1 minus x, which is a straight line. So when x is 0, y is 1, and when y is 0, x is 1. So that is the graph of y equals 1 minus x. Now I'll take the transformation of y equals mod fx. So mod of 1 minus x. Now transformation of mod fx is mirror on x-axis, take the reflection of down on up, and then erase the graph from third and fourth quadrant. Now I'll take the transformation of y equals minus mod of 1 minus x. So transformation of minus fx is rotate the graph 180 degrees about x-axis. I'll take the transformation y minus 1 minus mod of 1 minus x. So I'll need to shift the graph plus 1 units along y-axis. Now next again, I'll take mod fx, so which is 1 minus mod of 1 minus x. Now again I'll take the transformation. Then again I'll shift it. Now again from here, y equals mod of 1 minus mod of 1 minus mod of 1 minus x. So minus 1, 0, 1, 2 and 3. Now we just need to do that one more time. And then finally, transformation of another mod of x. So this is minus 2, minus 1, 0, 1, 2, 3 and 4. Now it is continuous for x belongs to a, but it is not differentiable at these points. So it is not differentiable at minus 2, minus 1, 0, 1, 2, 3 and 4. Discuss the continuity and differentiability of the function fx equals greatest integral function of x sin pi x when the value of x lies between minus 1 and 1. So what I'll do is I'll draw the graph of y equals sin pi x. So I'll draw the graph of sin x. Now for sin pi x, I'll divide every value with pi. So now here will be minus 1, 0 and this one will be plus 1. So I'll take two separate cases. Case 1, when the value of x lies minus 1 and 0. When x lies between -1 and 0, in that case, the value of sin x will also lie between -1 and 0. So here I can say the value of sin pi x will also lie between -1 and 0. Now if I'll multiply them, then when I'm multiplying two negative numbers, I'm bound to get a positive number. And because numerically their value lies between 0 and 1, so still their product will also lie between 0 and 1. So this value will lie between 0 and 1. So if I'll take their greatest integer function, so I'll write x sine pi x, this value will always be 0. So when x lies between -1 and 0, the value of greatest integer function of x sine pi x is 0. Now I'll take the second case. Now second case, when the value of x lies between 0 and 1. So when x lies between 0 and 1, the value of sin pi x, it will also lie between 0 and 1. So it will lie between 0 and 1. Now if I'll multiply it, I'll get this value as x sin pi x will always be greater than or equal to 0, but less than 1. It will be less than 1 because in order to achieve the value 1, for both of them, they have to be 1 simultaneously. But they are not 1 simultaneously at one point. So this value will always be less than 1. So in this case also, greatest integer function of x sin pi x is 0. So the given function fx in the interval -1 to 1 is nothing but a constant function which is 0. And any constant function in an open interval is both continuous as well as differentiable. So answer is, this function is continuous and differentiable in -1 to +1. Now here the question is, solve the equation greatest integer function of 2 cos x plus greater function of sin x is equal to -3. Now what I know is the value of 2 cos x will lie between -2 and +2, and the value of sin x will lie between -1 and +1. So in order to get this 2 cos x plus sin x as -3, the only way it is possible is when the value of greater function of 2 cos x is -2 and when the value of sin x it is -1. So that means greatest integer function of 2 cos x, it should be -2, and greatest integer function of sin x, it should be -1. That is, the value of 2 cos x should lie between -2 and -1. So if I'll divide by 2, I'll get -1 cos x is less than -1 by 2. And for sin x, I'll get this value should lie between -1 and 0. Now I'll need to find simultaneous solution of this equation. So when the value of cos x lies between -1 and -half, and when the value of sin x lies between -1 and 0. So what I'll do is, I'll draw both the graphs. So I'll draw the graph of cos x. Now because both the functions, they are periodic with period 2 pi. So I'll take up a 2 pi interval and then I'll draw both the graphs. This is 1. This is -1. This is pi by 2. It is pi. And this is 3 pi by 2 and it is 2 pi. So that is the graph of y equals cos x, and I'll need to find a region where the value of cos x lies between -1 and -1 by 2. So I'll need to find where it lies between -1 and -1 by 2. So these points, so they'll be, now cos x is 1 by 2 at pi by 3, and this is pi plus pi by 3, so there'll be 4 pi by 3. So that is, the value of cos x will lie between -1 and -1 by 2 when the value of x lies between 2 pi by 3 and 4 pi by 3. Now what about sin x? So I'll draw the graph of sin x. The value of sin x will lie between -1 and 0 when the value of x lies between pi and 2 pi. So now I need to take the intersection of these two conditions. So if I'll take the intersection of these two conditions, then I'll get the value of x as the value of x should be greater than pi but less than 4 pi by 3. So answer to this question is simply the value of x should lie between pi and 4 pi by 3. And finally we have this question. We need to find this integral from 0 to 10 greatest integral function of under root 10x upon x plus 1 dx. Now let us take this as a function y, which is under root of 10x upon x plus 1. Now in order to solve this integral, what we'll do is we'll draw the graph of this function and we'll draw it using transformation of greatest integral function. Before that, I'll differentiate this function. We'll find y dash. So it'll be 1 by 2 under root of 10x upon x plus 1 into 10, and here will be 1 upon x plus 1 whole square, so it will be greater than 0. So this function, it is strictly increasing function. So between 0 to 10, this function will be an increasing function. Now at 0, this value will be 0, and at 10, this value will be 10 by under root 11, and that is 3 point something. So if we draw this graph, so it will be some increasing function from 0 to 10. Now at 10, this value is 3 point something. Now we know for transformation of greatest integral function of x, we have to draw horizontal lines at integer points. So we have integer point at 1, at 2, and integer point at 3. So this is 1, 2, and 3. Now first we'll find these point of intersections. Now this point is when the value of this function is 1. So if we take this as 1, we'll get 10x upon x plus 1 will be equal to 1. So value of x here is 1 by 9. So this point is 1 by 9. Now for this, we'll put under root 10x upon x plus 1 equals to, now we square it, we'll get 10x equals 4x plus 4, or the value of x is 2 by 3. So this point will be 2 by 3, and then if we put it equals to 3, we get 10x upon x plus 1 will be 9. So we'll get value of x as 9. So this point will be 9. Now we know that in between any two lines, this greatest integral function, it comes to this bottom line. So here will be this 0. Here will be this value 1. Here it'll take the value 2. And in between 9 and 10, it'll take the value 3. Now this integral, it is nothing but it is this area. So value of this integral will be 1 into 2 by 3 minus 1 by 9 plus 2 into 9 minus 2 by 3 and plus 3 into 10 minus 9, which is 1, and this is 5 by 9 plus 18 minus 12 by 9 plus 3, 182 by 9. Now we need to find the value of 9i. The value of 9i is 182. So answer to this question is 182.